Hello, and welcome to question 12 of section 1A in Linear Algebra done right. So we basically wanted to show the associated property holds in the field of real and complex numbers. So first you're going to notice the n up here. That means we're dealing with n tuples. Those are going to be our elements in F. So first we start with the left-hand side and say that x1 to xn plus y1 to yn as n tuples, or vectors if you want to call them vectors, all in brackets, plus z1 to zn as an m tuple equals this up here, the left-hand side. And so you can use the addition of complex, vector addition property to add these two. Then you get x1 plus y1 comma x2 plus y2 and so on. I did all three in one step, so you can do that, and then you can add the z or z terms. Then you get x1 plus y1 plus z1 as your first term. This is wrong. Let me just fix it. That is an n tuple, not a sum. There you go. So you get an n tuple. Let's see if we can do the same for the right hand side. Looks like I've done the same mistake there, but we'll fix that when we get to it. So same thing. It's quite literally just the reverse. Start within the brackets, add all the components, y1 plus z1, comma, y2 plus z2, and then you get a vector. And then add that to this first vector, then you get x1 plus y1 plus z1 here, all the way to zn. Wow, I'm making a lot of mistakes in this one. Oh no, that's not a mistake, okay. Plus x2, y2, z2, all the way to xn, yn, zn is a single n tuple, not a sum. That's my mistake. Don't get confused by that. That is a vector, okay? And that's the same as the left-hand side. And that's the proof for question 12. I'll see you in the next one.